This is the Amp Hour Podcast. Released February 26th, 2025. Episode 689. A Jumperless Breadboard with Kevin Cappucio. Welcome to the Amp Hour. I'm Chris Campbell, Contextual Electronics.
And I'm Kevin Cappucio. I make Jumperless.
Hey, welcome, Kevin.
Hey, thanks for having me.
The Jumperless is probably something people have seen. It is the backlit, awesome, like interactive, blinky, and actually functional prototyping platform. Is that a good way to say it?
Yeah, as good as any. I don't have a good elevator pitch for it, so that'll
We're going to
work.
develop that. We'll get to it by the end of the show. We're going to have an elevator pitch. It's going to be a tight 5. Tight 5 seconds. Yeah, right. That's great.
Cut it out of different parts of the show later on.
Yeah, exactly. We'll just piece it together, and then, when the V6 is ready, then you can highlight the amp hour in your promo of it, of course. Why wouldn't you? You lead with the strong thing, right?
Yeah.
But you are in V5. You just funded this back in November of 2024. So maybe, how did we get to V5, right? So we've had multiple versions. V5 is kind of getting towards production or in production. Yeah. How did we get there?
So, like V1, which I'm calling the OG, the original gangster
OG.
Now. It has been retconned. I mean, a lot of those decisions were like, I wasn't sure it was going to work. There's so much to it that you're like, I was just being more conservative with what I was willing to shove in there. But now...
but why were you building in the first place? I mean, like, a lot of people, like, look at a breadboard on their bench, and they're like, oh, yeah, they're sitting there. That's good. And they say, this could be more... I've seen, like, power supplies, things that kind of go onto it. But this is building ground up. This is, like, the breadboard is electronics now. So that feels different to me.
Yeah, I mean, I don't want to take credit for the idea. I feel like everyone's had this idea at some point. Like doing, wiring breadboards, then you're just like, oh, why can't I just, do this and whatever.
Yeah, these wires are so annoying. What if I didn't need them?
Yeah. And so then, like, when you get down to it, it ends up being really complicated. Like there's old forum posts of people doing like mixers for, for audio stuff. And it's like one of those. They're
doing mixers for audio on a breadboard?
No, it's the same circuit, like same chips, analog crossbar switches.
I see.
Yeah, and it's just it gets unwieldy very quick. Yeah, and so
those little strips of metal are doing quite a bit, huh?
Yeah.
When they have to do a little bit more intelligent things in there. So I mean, and a standard breadboard too is not like a small. Oh, I have one here. I'll have it as a reference point. And foreshadowing, it's got an RP2040 on it. So maybe we're matching the thing, but it's got a bus, it's got a whole bunch of holes on here, right? And then the one I'm holding, obviously people aren't going to see what we're talking about. It's a bunch of overlaid wires, so it is a mess. This is a terrible design, and signal integrity wise, it's a bad idea. But is it convenient? So were you trying to make it more convenient, more easy, more accessible from a learning perspective? What was the spark that made you like jump and say, oh, I should build this?
I mean, I really just did it because it sounded hard. But
I like that. That's great. Best answer.
The idea of being able to,
it was your Everest.
It's like so many electronics just boil down to like a screen and a microcontroller and like a couple buttons. And I was like, all right, this is finally a project that's like interesting. I didn't really have education in mind, and I still kind of like, I think with V5, it's kind of mature enough that I can consider it like an educational thing. But I think for stuff like, reading out ROMs or like doing like weird chip stuff that you just simply couldn't do with wires, where you're taking in some signal and then rewiring it based on the signal. You could make like weird Turing machines with that.
Yeah.
That was kind of what I was at first going for. And then everyone came up with better ideas for what to do with it.
It's like, it's so much work to move this one wire to a different slot. But what if I just redesign the whole backplane so that it it was just a single switch, but I also have to do it in software, and I have to write that software, and I have to.
Yeah,
I guess you don't need software in the new one, right? But like, yeah, there's a lot of layers that make that one wire jump really possible. So like, this is like Sisyphean task that is it's worth doing. I like it.
The idea is like, if enough people out there have them, like people always come up with like cool stuff to do with them. Like I just felt like it was a tool that should have been out there. Mm-hmm. Like just if someone has an idea to do with it, like it's kind of a cool, back end tool to use in something else.
Yeah. Well, okay. So now we've did some of the motivation. I'd say maybe can we do some word pictures now for the current day, like the V5 that has this. It has like a stylus. So maybe you can just kind of describe some of the things that someone might open up the box, start using it with.
Yeah, I think that was the main sticking point with the original Jumperless. I think even Dave did like an unboxing. I sent it into the mailbag, and like, yeah, because my software was crap, but like crashed, and it was just, but yeah, and like,
sending Dave software is always a bad idea, just so that the audience knows that I think that other people think. It's just like every time someone's like, oh, and I sent you software, it's like, oh boy.
that seemed to be the consensus.
You are in the Dave arena of it better be precisely what he thinks it should be.
Yeah.
Okay.
Yeah, and so that, getting your face on a screen while you're trying to, prototype something isn't always the best. So yeah, that's what brought V5 into existence. I felt like I hacked a probe onto the original Jumperless. So when I made it, I did not think about there being a probe. That just never even crossed my mind. And then I had a bunch of units made, and then later I figured out this is one of the cool things you could do. You can connect each row to the ADC one at a time, and you can measure each row, and you can look for a signal coming out of the probe. And it does it like 200 times a second. So that's how
that is pretty cool.
The original Jumperless probe worked. And yeah, then, people were using them for audio stuff, like, wanting to do like, synth kind of live mixing. Mm-hmm. And that process requires it to disconnect everything, because it has to, everything's disconnected, and then it goes one at a time. And I was like, all right, how can I get a probe to work without having to disconnect anything? And so, so the V5 now, it's it's a nuts setup. It uses one pin to read all the probe pads. And so it just spits out 3.3 volts on the probe, and it's a resistor divider. There's 100 resistors in it, and it reads it with an ADC.
Okay.
Yeah.
Okay. So, well, let me try and do some of the interface, just kind of the high level things on this. So, upper left corner, there's a little scroll wheel thingy that helps you interface with the LEDs that are underneath the breadboard. That's a 3D printed breadboard, like the actual, like the waffle iron looking thing, or the waffle thing.
Yeah, that's it's SLS by GLC.
Nice. Okay, cool. And then there is a interface at the top, so you can plug in like a Arduino Nano look like.
Yeah,
or
anything in that footprint.
Okay. But then you don't need the Nano either, right? Because this has its own intelligence on the Jumperless as well, like the chip in the upper right that's kind of running the show, right? What is that chipset?
Yeah, it's a RP2350 now.
Okay.
But yeah, no, you don't need the Nano. That's basically just like more breadboard. That's a convenient place to put it, and so I can keep it exactly square.
Okay. Oh, nice. Yeah. Okay. So someone could put a Nano up there, maybe write their own code, interface with a sensor, route it through the switch bar matrix that connects it down to the breadboard portion. But they could also directly program the RP2350. Is that right?
Yes. And it'll take commands from the Nano over UART. So if you hook up its UART lines,
that's really cool.
You could do anything that you would do over serial.
Okay. Okay. And then there's some big chonkers underneath the Nano footprint. What are those things? Oh yeah,
that's that's the power supply. So that's a charge pump circuit. It's a LM2660 MX. Okay. And yeah, that's how I get plus minus 9 volts for the crossbar switches.
Oh, I didn't realize that was necessary. Okay, that's an interesting. I definitely want to come back to that. Okay. Then we have what looks like a 3.5 millimeter jack on the right side of the board.
Yes.
Is that yeah? And that goes out through a really nice looking cable actually
Yeah.
to the probe. And the probe is another PCB. Any intelligence, or is it just signal routing on the probe?
So the probe is really simple. There's a WS2811, like a RGB addressable LED, but it's like just the chip in its own package, so you can
Yeah.
bring your own LEDs.
Cool.
And so I have it running cyan, white, and pink LEDs instead of RGB, which is kind of fun.
Yeah.
But yeah, there's really not much in the probe. That's it. It's just an LED power ground. There's an analog line, so there's a switch on the probe that allows you to switch it over to be a routable input, so that can go anywhere on the breadboard you want. It's a super weird
interesting.
circular thing.
Okay.
But
Yeah.
it makes it so, because you have to deal with 9-volt tolerance versus 3-volt, 5-volt tolerance.
Yeah. Okay.
And so if you want to arbitrarily poke stuff out, you want 9-volt tolerance. So that's what that switch does.
Got it. Okay. Yeah, this is great because this is like now we're kind of like building it up in people's minds and like starting to see some of the, like minus 9 volt, like okay, Kevin's really lining up for so
Yeah, sorry.
That's-
I've been in the weeds for so long. It's
I
like
know
it's
yeah,
so
you're like,
easy
why
for me
don't
to go
people
like
know how to deal with all these crazy problems like
I just go like depth first immediately for everything.
yeah no that's great and I mean we'll have links to the page and blinking lights is very important for all this stuff too to just get the high level type things.
Fun. We can come back to it, but it's the probe is really hacky and really weird if you want to, because it's running like 6 signals over 4 lines on the jack. It runs.
Is it
It's
DRS?
reading. Yeah.
Okay.
It's actually the jacks or whatever. But yeah, so it's running the LEDs, like the LED data, over the same line as it reads 2 buttons. It uses the pull-ups and pull-downs to tell you which button's pressed. And then when you're not checking the button, it's sending LED data. It's, yeah.
Nice. That's great.
Yeah.
And it's got that crazy, I mean, the WS2811 or 12, I guess, is what most people use. It has that super tight timing stuff too, right? So I'm guessing that's going into like a PIO or something on the RP.
Yeah. I mean, yeah, it's weird what they will put up with, like with so many things where you're...
Yeah. And are you using it? You're using it as an LED, but like with that serial to multi-drop kind of like string LEDs are. It's really like almost like a port expander as well. Are you using like as a port expander or just to drive the LEDs directly?
Yeah, no, it's just one LED, so it's not. I mean, I guess you could kind of think of it as a port expander because it's driving 3 LEDs with one
Yeah,
pin.
that's what I was. Yeah, right.
But there is a lot of space for pads, so there's an invitation inside there to make this to do whatever the hell else you want it to do. With
Yeah,
it.
yeah. There's a lot of room. You could squeeze more stuff on there, right?
Yeah.
That's great. Okay, and then I see seeing the buttons on here. So there's a remove and a connect button. So maybe explain those real quick.
Yeah. So there's modes. So remove will, as you touch something, it will remove that connection.
Okay.
And connect will, you touch something and then you're holding a connection, you put it somewhere else, and it'll, connect those up instantly.
Got it. So this is like, so now I'm holding a probe in my hand, so it looks like an oscilloscope style probe. I touch it to the one of the rows one of the columns, because we're going to talk about the columns being the.
We're going to mess that up the whole time. I still say rows.
Yeah.
Don't worry about it.
Yeah, okay, let's say rows then. That's easy. Okay, so the row, which would be like 5 connected, like a strip of metal would normally be connected to them on a breadboard. So I'm going to touch a row, which is effectively five connections on the breadboard. I hit connect, and I could touch to the row, hit connect, and then hit a different row and hit connect. Is that right? Or what is the?
You just hit connect once, so there's a mode, and the logo lights up, and that will show you what mode you're in.
Cool.
And the probe has 3 LEDs that show you what mode you're in too.
Got it. Okay, cool.
So when you're in connect mode, anything you touch, just touch one, touch something else, and that will connect.
Cool. Okay. Yeah. And so I would do that maybe then so I guess I'm looking at just like the cover image for the Jumperless V5. So there's a resistor that's kind of far away from a LED leg, and these are through hole. So I would touch basically on one of the legs of the resistor, because that's connected to the switch matrix, and then to the leg of the LED, and those two things then would just light up and be like, I know how to do this.
Yeah, yeah, it figures it out.
That's pretty cool.
Yeah, yeah. It was. At some point, we can get into the routing algorithm. It's really,
That's
really fun.
Yeah, I'm just saying these strips of metal and little wires, they're doing a lot of work compared to
Yeah.
hours, days, weeks of your life. Years? I don't know.
It would have been less time, though, if I'd just shown up to everybody's house and just wired their breadboards for them. That would have been the easy way to do all this.
Yeah. Lights included, everything.
Yeah.
Yeah. Okay.
Yeah.
Yeah. I wonder, like, one thing I've wondered about, we had Ben Eater on the show a long time ago. And he's got amazing courses, and now he sells kits and stuff like that. But I'm always amazed that he's able to have people do his course and then deal with all these wires. Do you think that there are people that are having fewer of these kind of hiccups from I think everybody listening who has used the breadboard before, they're like, the circuit isn't working, and they kind of like tap the top of the wires, and then the one wire kind of finds its way further into the hole, and you're like, oh. Like number of hours I lost in the lab at school. Like, yeah.
My God. That was all labs in school. It's like,
yeah, exactly. Just check every connection.
Yeah.
So is it better now? I mean, like, is this also solving that problem, or that's not even the point?
Yeah, no, it does. I mean, that's, if it says it's connected, it is connected.
Okay, great.
I think just having the feedback with the LEDs underneath too, it kind of gets stuff, like on your breadboard that you're just showing me, like everything's covered. So some wire is underneath another wire, and it's always hard to,
see what's you're like kind of like thumbing through it. You're like, like the hackers that are like going to hotwire the car. They're always separating the wires. You have to do that same thing, but then that also might jostle things out of the way. So yeah, you're right. I mean, like, and actually that brings up a good point about this board is that all of these things are backlit as well. So how many LEDs are on the back of this thing? Is there a view of this without the SLA cover on it?
I mean, I have one right here. I don't know if I've posted one, but
okay.
Yeah, maybe there's 445 of them total.
And those are all RGB?
Yeah, so this is one long string of, they're like XL1010s, so they're 1 by 1 millimeter.
Okay.
Yeah.
You should, if we could get a close-up, but that would be very interesting to see.
Yeah, I'll post it.
It seems like this is a very complex routing, like on PCB as well, right? Like this is.
Oh yeah, it's so dense.
Oh my gosh.
Yeah. I mean, I have. I actually sanded some off, which also more visual stuff, but.
Oh yeah, that's nice. Okay, so we'll have Kevin hopefully upload some. Probably upload them, post them somewhere else, so there's not just captive on the amp hour page. So we'll put some links though. Of course. Links to this stuff. This is the deep stuff that we want to hear.
Routing is intense. There's like sometimes there's times where you're routing this and you're like, I don't know if I can get that wire there. Like, I don't know if that's gonna fit.
What is the specs of the PCB? Like, how many layers on there?
It's 4 layers.
Oh, okay.
And yeah, basically everything I'm doing is pushing their capabilities like right to the edge. What do they say? 6 mil traces or something. I'm doing, 5.5 to fit more through. But yeah, so you've got the backlit breadboard. A fun part is the clips, because I had to have
so this is now
made.
The physical, like how it's actually physically connected now?
Well, the metal spring clips, like that's no one will sell those to you. Like it's not a thing you can buy.
Well, wouldn't you go to the breadboard headquarters or all of the super rich breadboard makers of the world, right? I'm sure there's so many of them.
I don't know how like Adafruit just started selling the strips. I don't know how
Really?
they got it. Like, yeah.
Maybe just paying someone to rip them apart and throw them in a bin and
I guess so. I actually called a few companies in Taiwan when I was first starting this, and they're like, no way. I was like, why? Who cares? Just send me a roll of that. I don't know. They're like really weird about it.
Are there multiple? Like, have you touched base with actual breadboard companies? Are there I have to imagine it's like one company is making all the breadboards in the world. Is that likely? I don't know.
No, there's so 3M is the main white label manufacturer of breadboards.
They're white labeling other people, or they are making things that are being white labeled?
They're making things that are being white labeled, yeah.
Interesting. I would not have guessed that.
I know, right? And there's like five different breadboards you'll see out there.
Is it because they're actually selling the sticky stuff on the back that often on breadboards that I never ever use?
That's just like an option that comes with the tape.
Yeah. Well, actually, we just charge a lot for those sticky things that you put on your wall to hang up photos, but then we just throw plastic on it. So that's how we.
Yeah. But yeah, so there's the variance in quality of breadboards is kind of insane. Like,
yeah.
I hear that a lot from people like, oh, I don't like breadboards. They always like, get all screwed up, and it's like you haven't used a good breadboard, man.
Yeah.
Yeah. A nice thing about these two, which actually started from like a manufacturing kind of mistake, is that the shells of these breadboards actually come off. So if you like jam a clip, like if you screw up a clip really bad, you can actually peel the whole plastic shell off and just replace one clip and put it all back together. Yeah.
Okay. Use replaceable parts inside.
Yeah.
Okay.
And it just happened because like the tolerances, like when they printed them on one batch, were really like they're a bit smaller, so they're loose. Yeah.
That's interesting.
Turned out to be a great feature.
Okay, so if I am inserting a resistor leg, for instance, into a row, one of the 5 holes in a row, and hopefully people are visualizing what Kevin and I are looking at because it's tougher with audio sometimes. If I'm inserting that into a row, that is hitting the metal leg is contacting the metal clip that's underneath the row. And then what is the interface from the metal clip to the PCB?
So this is a specially made thing, but they have tabs, so they actually solder down. So each side of the clip has a little leg that goes down, and it's an SMD part now.
Really?
Yeah.
So then the shell, like you mentioned, so the SLA shell that is going over top of the overall unit, that is not mechanically connected normally to the clips unless something went wrong.
What? Like, they don't really touch the clips much. You mean like the metal or
so
the
it's just
plastic?
it's just like there we go. Okay, so I've got another photo. Hopefully we'll get in here. Oh, interesting. Oh, so each.
Yeah.
Okay, that is not what I was thinking this looked like. This is a great photo. I'm gonna have Kevin post this one too, hopefully. But this looks like it looks like a honeycomb almost underneath there.
Yeah.
I thought, and I'm going to do hand symbols here. I thought that the leg was coming down and just touching the top of like a bent metal kind of dome underneath all the lines, all of the 5 holes in a row. But each one has its own captive kind of like tulip shape thing that the leg goes into, and that is what keeps tension on each leg that might go into a hole.
Yes. Huh. Yeah. So these work. Yeah, it would work without the shell actually, and these especially because they're soldered down. So they.
Yeah, that's like operation mode. Like you hit the wrong one. And,
yeah.
Okay. So then, so then the light comes up through. So again, like now we have like a little bent metal tulip shell thing. The light comes up through the middle of the tulip. Is that right?
Yeah. So the benefits of Taiwan blowing me off about buying breadboard things is I could make them custom, and so I had them put holes in the bottom. Wow. So each, I know it's a visual thing. I have links to that because I sell these like at cost because I just want other people to make cool breadboard stuff, and it's like no one else wants to, do the whole setup for it.
Right.
But yeah, so it's like, so they sit over LEDs. Like there's little notches in the bottom.
Yes. This is a more descriptive episode than I thought it was going to be. I should have figured it, but it's really interesting. Okay, so then because then those so now we got five holes in a row, 5 LEDs underneath the row, 5 tulips. I'm just going to keep calling them on a metal strip that's soldered down into the board. But the 5 holes that are electrically connected on the strip, then those contact the PCB because they're through hole. That basically it's just now you have a net that's hitting your PCB.
Yeah. So those are soldered down. So all 5 of those holes go to those 2 solder joints at the top and bottom.
Huh. And that seems like that would be a tough process then, because like these are also standing themselves up as well. Like do you have to have like a jig to make these things vertical, or how does that work?
So my spring clip manufacturer actually offered to make this because so Elecro does these for me, and they actually they do them by hand. They
Oh no.
they use the shells as a jig, so you put them all in
Okay.
upside down,
Oh, I see. Got
and
it.
then you can like if
Then
none
you
of
gotta
them
wiggle
are bent,
it in, you do a little
yeah,
vibration, and okay.
yeah,
Interesting.
yeah,
Well, I think we should state this is not the cheapest thing. It is super cool, but it is not cheap.
yeah.
I think breadboard. I think what $5 maybe, $10. How much does this cost, Kevin?
They're $369 on Crowd Supply. Yeah,
Okay. Yeah.
yeah,
And these are very. I think we're painting a very
Yeah.
good picture though of like how complex these are, both manufacturing, electrically, programmatically. Yeah. So maybe not anyone's first breadboard, but maybe their favorite
Yeah.
breadboard.
Yes. I mean, and that's the whole thing with the UI is it's supposed to kind of be
Yeah.
fun. Like,
Yeah.
I understand it's expensive. I really hope someone clones it for way cheaper. I'm inviting people to clone this.
Do it.
So,
Yeah. Come on,
Yeah.
folks. Get there. Well, let's talk about the next most expensive. Well, probably the most expensive thing on this thing, which is this crossbar switch matrix on the back of these. So if you look at I had seen photos of the back of this thing, and I'm like, oh wow, they almost look like PLCCs, but what are they? Just like QFNs on the back?
they're QFN 44s, I think. Yeah.
Okay. And what is the part number on those things?
Those are CH446Q.
Okay. CH sounds like WCH.
Yes,
like
I know. That's the craziest
makers?
company in the world. They make all of their products are bangers.
10 cent microcontrollers and also analog crossbar matrices.
Yeah, and like the USB serial chip that everyone uses now, like the new FTDI.
Oh yeah, that's true.
Like, that's it.
That is always the first memory where it was like, this is some Chinese USB to serial, but go to the Swiss site, or no, I thought it was Swiss because it had CH in the name, right? Because that's like the Swiss TLD. And then it was just like this shady download for my Windows computer. I'm like, I am not doing that. And now I use their parts. And like that's just how it goes with like bottom up innovation, right? But
Yeah.
anyways, what is their stated use of this thing? Why are they saying they're using this?
So it is a clone. This goes so far back. So it's kind of a clone that they upgraded quite a bit. So there was a Zarlink, I think was the first company that made them, was an MT8816. And that was in a chunky PLCC package.
Got it.
And then they got bought like 5 times. Like there's like a data sheet
private
with like
equity is involved. Huh?
yeah. And then they're like Mitel, and then I think they're eventually Microchip product got abandoned. So yeah, it's a clone of those. They're for a lot of them are for like PBX boards. Like if you ever, telephone switch.
Yeah.
Or also for
I guess
video.
connecting lines at 90 volts or whatever, and
Yeah.
I guess PBX was digital. Never mind, that was not 90 volts. That was
Yeah,
I'm
just
thinking like switch matrices, stuff like that. Yeah,
I mean, that's where the name comes from, is the crossbar switches. Yeah.
Yeah. Right. Okay.
Yeah. And they also use them for video. Like if you have like a bunch of security cameras on a thing.
Oh, interesting.
Which also speaks to the fact that frequency is not an issue on these things. Like
interesting.
I think it's 50 megahertz is like what they're kind of rated for, like the switches.
Wow. Yeah.
Which is well above what a breadboard physically could handle.
Right. That's right. Yeah, exactly. That's interesting. Yeah, I guess probably just the resistor leg to tulip connection. Probably you've already have some discontinuity enough there that you're starting to deal with that, right?
Yeah. What else?
Well, it is. So how did you find this chip? First off, like the Zarlink or the WCH or whatever.
I mean, that was early research. I mean, I think I even have my old proofs of concept, but I was just,
nice.
How can I do this? How do I connect a bunch of things to a bunch of other things? I think like Analog Devices has some that are like, 16 by 16 or something, but they're like $50 a pop.
Good old ADI.
So just random chip I found. And then I think someone there's an old GitHub issue on my old breadware is what it used to be called.
Okay.
And someone was like, hey, can a CH446 be used instead? And I was like, No
Yes,
way.
they
You
can.
just crack the case.
Crowdsourcing,
and what
that's great. Yeah.
what they added that was also huge for this was a serial addressing mode. So the old ones, the
Oh, it's all
MT16 is parallel.
4 pins to get 16 connections or whatever, and
Yeah, it's 4
okay.
and then 3 and then like a data like on or off and then like a chip
like a
select.
row column kind of thing. Yeah.
Yeah.
Interesting. Huh.
And these ones do both.
Okay.
But I mean, now I've already written the PIO state machine for that. So if anyone else is using them, it's pretty easy now.
This is kind of what I remember. Oh, who was it? There was an FPGA maker that started talking about FPAAs, like field programmable analog arrays, and I always thought that this kind of like really this is a switch matrices, but then I thought they were going to put like stuff in line with it, like how Cypress now PSOC or the Cypress PSOC had some like inline analog processing. You could kind of switch stuff in or out. But at the end of the day, it's like this is what I was thinking about it was doing, and then they were trying to do all this other stuff.
This is what I'm basically hacking one of those into existence with somewhat discrete parts. Like
right, exactly.
There's
the
FPAAs.
This is an FPAA, right?
Yeah, they have like they'll have like 2. They're like more about like running high frequency stuff. I think.
Yeah.
Someone made a SuperCon like badge hack with those. Like
Okay. Interesting.
But it's like 4 blocks. Like it's basically like 3 or 4 lines in. And then there's also another Jumperless breadboard that came out that uses one of those Cypress PSOCs. They use like the internal, they do have a routing matrix. It's just
okay.
Yeah.
Well, and it comes down to the same problem I kind of always think about. So like I think I first started looking at these one way back in the day when I was at Keithley. And I'm like, okay, there's no way it's not a relay, right? It's not like you're not connecting 2 pieces of metal. You're going through basically analog switches, but not one of them either, right? You're doing multiples now because it's truly a crossbar. You need to have multiple FETs kind of all turned on in the right, not even FETs, I guess it's groups of FETs. So like signal path-wise, it's like, yes, it works high frequency, but it's not low resistance, right? And that's one thing that you showed on your Blue Sky recently as well.
Yeah. Oh, that is the main drawback. If people are about to click buy, hold on till the end of the sentence. But yeah, so they the crossbar switches have like a total connection on a Jumperless is 85 ohms. Yeah, so it's like 40 something per switch because it has to go through 1 to start and then 1 to end. The thing you saw on Blue Sky is now, so how the routing algorithm works now is that any unused possible paths, it makes your paths first and then makes a bunch of duplicates, like fills up the rest of the board with redundant paths. And now it gets down to like 25 ohms.
That's great.
Yeah.
I think some of this is just you need some different marketing, and you could say intelligently routed analog algorithms, something AI.
Yeah.
I mean, Kevin, you're gonna be swimming in money by the end of this show. I mean, like some VCs chucking money at their podcast player, And AMPR only takes a 10% cut. I don't know if you knew that. So
yeah, at least I can do
consultant.
intelligent routing. People have used that term, and I'm like, wait, what? It's just a mess of switch statements.
Feel intelligent. Yeah, it's like that the astronaut meme.
Yeah.
Wait, it's all switch statements? Always was.
But yeah, and it's weird because I want to make it arbitrarily routable. What is it? Something like 110 nodes. I've got 60 on the breadboard and then 20 on the 20 something for the Nano. And then I have all the there's, 8 GPIOs from the thing, from the RP2350. There's, 6 ADCs now.
Wow.
There's the rails, and then there's 2 DACs, 2 just other DACs. But yeah, so those are all nodes that I have to, and turning a bunch of 8x16 crossbar switches into 100 something by 100 something crossbar switch is a really weird problem.
Yeah. Okay,
Yeah.
so then that interface now what is the interface RP2350 to the range of crossbar switches? Are they all? Is it a bus? I don't actually know.
So yeah, it's a bus, but they all have their own chip select lines. So
Okay.
you send the data out to all of them, but then whichever one gets its chip select toggled
Okay.
at the right time, then that one is what
Got it.
does it.
So you need 12 chip selects because of 12.
Yeah.
Got it. Okay.
Yeah.
But probably relatively slow. Like you're not switching those. You can do 50 megahertz through the signal path, but you're not switching at 50 megahertz. So that's
It's
not
actually
too bad.
it's pure CMOS, so it's so fast. It's like a
Oh,
couple
great.
nanoseconds hold time for
Oh wow.
a chip select. Yeah, it's so
Oh
fast.
wow. Yeah.
Yeah, no, it works at like maximum clock. Like is so making a whole set of connections is like a couple microseconds. And like if
Okay.
I was pushing it, I could do faster. Like if I wanted to not, you know, you can take out some delays in the code if you wanted to.
Yeah. 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 Huh. Interesting. I mean, is there a use case for that to need to switch that fast, or is it more of a just make versus break kind of speeds?
Yeah, there really isn't. Like I'm sure someone will have a good one, but it's just because
Yes.
it's like I think it's just because it's so dead simple in there. Like there's not that many gates it's going through inside the crossbar switch, so it could just might as well be as fast as you can send it.
Yeah. Okay. What about
there are some things that
Yeah. Go ahead.
like the old jumperless routing algorithm, like that, connects each row to a certain place. I think it's like 300 times a second, probably faster than it needs to be. It's scanning the whole board by sending a whole set of connections one after another.
Huh.
And that's not even as fast as it could go.
And what is the purpose of that though?
Well, that's just to scan the board, just to make it snappy. So, if you're touching the probe to a certain row,
Oh, okay.
you
So
want
you're
it to light up
you're
the second you touch it.
got it. So you're basically saying, are you on yet? Or sorry, do you have the probe touching you? Do you have the probe touching you? So like, this
Yeah.
is the mode that it's in. So now you're looking at the probe, you're looking at the switch, or the currently active switch on one of your pins, I guess. So it's basically routing to the detect pin on the RP2350 and the other detect pins on the probe, and you're basically saying you're just doing like a continuity test almost to 300
Yeah.
switches or 300 outputs.
Yeah. It also, like, the older probe also outputs PWM. So, like, it would know the difference between, something just held high with a wire versus
Ah, okay. Yeah.
it can tell if it's floating. It's yeah. That's
There's a lot of complex things going on.
yeah, it wiggles the pull-ups, which is like one of my favorite tricks. Like, if you're reading something and you turn the internal pull-up on and it stays low, then it's like actually grounded.
Ah,
But if
versus
it
like tri-stated and
yeah, just kind of floating, it would move with that.
Oh.
Yeah.
Okay.
But yeah,
What
no,
I'm trying to like rectify in my mind is that like you're on V5. You've spent a ton of time on this. I'm like, how the heck did Kevin come up with it? But like you've integrated these things over time. So like maybe just step back a couple of revs as well. Like I guess on the first one, did it have all of the DACs, all the ADCs, all the switches, all that stuff? Like maybe I know we've been jumping back and forth the time, but like on the first one, did it have what was the kind of the basic, like the high level view of it like this?
yeah, actually, what's interesting is that didn't change that much. Like,
Okay.
I
Oh,
went
interesting.
through before V1, I went through like, I probably, 4 or 5 times of just deleting the matrix and starting over. And it's just a lot of staring at it and just trying to find counter examples of like, if I want to get there, like this switch will turn on here and connect it to there. And then how will that get to the next one? And so basically the whole schematic was made by just staring at it for weeks, years actually now. But yeah, and so it's actually fairly similar to the old one, like the routing matrix and how it's all wired.
Okay. What is the story behind? So I'm looking at the backside silk screen and the chips on there, and ABILCD EFJKGH? Is it like that you added you had 8 chips, then you went to 12 chips, and you just named them as you went through time, or?
No, okay, yes. So it's a routing thing. Okay, yes. So you got that. Those are the names of the chips because some people think it's like a secret code or something, and it's
Yes, Decliba.
yeah. So yeah, no, it's they're lettered A through L. So the special function chips, the why it's out of order like that. I mean, first it's also mirrored. So
Yeah.
from the front of the board, A is on the top left side.
I see.
But
Yeah, that makes sense.
the special function chips have connections to all of them, and those are like,
why aren't the letters backwards? Sorry.
oh man, missed the opportunity to do that.
Yeah. You could have really made people be like, "Ooh, this rune looks just like a backwards C."
Yeah. So how? I mean, I hope if you care, you're looking at the schematic because it's really complicated. But the idea is every chip has a connection to every other chip on the breadboard. So there's a section of 8 breadboard chips that covers the simple, like, just across, from one row to another. And then there's 4 above it on the schematic, like right in the middle. Those have a connection to every other chip, like all of them. And so that's another path that you can make. If you're routing something, like if you
So it's actually a crossbar of crossbars. That's what I'm getting here.
Yeah, it's a Kloss network kind of. If you want to Wikipedia that.
Okay.
Yeah, and except the difference is like the old crossbars, like those are basically zero resistance. You could go through as many as you want. So the old way of routing, you'd basically go up hierarchically and then back down to if you want to fan out 20 crossbars to another 20 crossbars, it's easier to just kind of like funnel them into a couple and then funnel them back out into another
Bus
20.
Method. Yeah. Okay.
And this, because of the switch resistance, you can't do that. Like you want to minimize that as much as possible. So it has to be kind of weird and flat. But that is why the special function chips, IJKL, are right in the middle. Is because
they have the most external connections out to the other chips.
Yeah, they need it.
That makes more sense than I thought it was going to make.
Yeah, it's
I
weird.
Thought you just got it. You just forgot to label a couple of them or something.
No, if there's any part on this board that you're looking at, I've spent a couple dozen hours.
Yeah.
Worrying about it. Yeah.
I'm looking at the schematic as well. So it doesn't seem like it has all the LEDs on it, or are they just indicated
they're
in
in
ways
another
that
page because
No,
there's like
LED
a little
page.
square bottom left. All the LEDs are down here.
Okay.
But yeah, I mean it's bigger than the rest of the schematic, like by area. Yeah, and I guess you can also see on the if you're reading along at home and you're looking at the schematic, there's a lot of op-amp buffers. There's actually a weird power supply thing. I have not seen a lot of people do it, but it actually works great. So an L272D, it's a power op-amp. They're meant for like the right
I've seen this
head.
before with like a huge front end, right? So like they have like really powerful transistors to crank some power through the output stage.
Yeah, they can do like an amp.
Yeah.
It's crazy.
Yeah.
And that's how I'm doing all my power supplies, which is super weird. Getting like a little weak DAC signal from a microchip DAC, and then it scales and shifts it. So I get like 0 to 4.96 volts from the the I2C DAC, and then that goes into one of those L272s, and it buffers them up to plus minus 8 volts, and can push as much power as the power supply is willing to give it.
So why do that versus like, I guess you wanted a programmable supply. I'm trying to now think about when I've seen programmable supplies. My brain is mush these days. When I've seen programmable supplies in the past, I guess they're doing the same kind of thing, a DAC, but then they might just like have a output driver stage. So I guess you're just kind of compacting that down into a single chipset, huh?
Yeah, I mean, like, and some of those like things where you could program like as a power supply, they don't go down to like 1 volt. They don't go below 1 volt or something.
Okay.
So if you want to, if you want to do a sine wave, you're not going to do that.
I see. Yeah.
Yeah. And because this board's so dense, it kind of requires being very simple about things. There's
right. Use the integrated components versus making everything like discrete and optimized.
Yeah. There's that always happens with like power supply people, and they're like, oh, just use this circuit, and you're like, dude, that's like 55 parts. Like, just like, come on.
You have this much room.
Yeah.
Well, let's talk about some of the other things that are on here. Well, let's talk about actually, you're on the power side. So 9 volts. You said, it says 8 volts on here, but so you need 9 volts to power the switches or something else? Yeah.
So 9 volts is like the switch supply, and then there's the dropout from all the things. So the power supply is 8 volts. It's easy to say anything you're dealing with is 8 volts, but everything is powered with 9 volts. But yeah, so I am driving these CH446Qs way out of spec. So they're...
you set it on the amp hour.
I did, yeah.
WCH is going to come after you.
I mean, props to them for them not blowing up, actually.
Yeah, right.
Just crazy. But yeah, so how analog crossbar switches work, they... just because it's pure CMOS, like their on resistance goes down as their power supply spread increases. By giving them more voltage. Okay. It's because it's like, I think it's because it's driving the MOS, like the semiconductor in there harder. And so it's like more on. You're
saying like, so the VGS isn't at the threshold voltage, it's at some significantly higher, like the most optimal driver of that would be.
Yeah.
Really I have really, really on.
Yeah. I have a like a transistor level, like, have you ever used Falstad? Like
of course, yeah.
Yeah, that's my favorite circuit simulator. It's so simple. Yeah. I'll put it in your show notes. There's a link that you can play with an analog crossbar switch, like at the transistor level. It's fun.
Okay, great. Yeah. So what is it spec'd for? Is it like 5 volt?
14.6 is what its absolute maximum. Oh, and I'm doing 18. So I guess maybe not that far out of spec, but...
plus to minus. I see. Okay. Yeah. I see.
And that's kind of like the diminishing returns place. Like I've, tried it with plus minus 12 volts. It doesn't help and kills them pretty easily. But yeah, so that gets like, I think they're in the data sheet for the crossbars, they're like 65 ohms. And when I do this, it's 45 ohms.
Okay. Interesting.
Yeah.
What's the net effect of like, so now if it was 65 versus 45 and someone had a circuit, I guess, what is the ultimate, like, are people using this product or, that you think are going to be using it for like just driving current through LEDs? Are they, driving SPI chips or like, I guess that becomes more of an application thing. Maybe the synthesizer example, like you mentioned, right? There's not a lot of current flowing through. There's often like voltage signals and like bleeps and blorps and stuff, right? But like, what would be the net effect to the user, right?
So if you're drawing zero current, for digital signals going into a digital input, they're really not pushing any current. Like resistance doesn't cause any voltage drop, so it's not going to
It would cause like filter stuff with like latent capacitance, I imagine, right? You get the R of the path and then the C of the pin and stuff like that. But okay, right?
Not at frequencies you'd hear.
Yeah, exactly. Yeah, exactly.
But yeah, I mean that is a bummer. That is like it doesn't, for any sort of like digital stuff, it doesn't really have a big effect, especially because it's all even. So they all, any given path kind of has the same resistance as the path next to it.
Mm-hmm. So kind of.
But for power, it does. It's annoying that certain, like, especially like ESP32s when they're starting up, draw a ton of power.
Yeah.
And they like don't work unless you stack that connection as much as you can, and
okay. Yeah. Got it. So it's powering of something that's on the board more so than like part to part on the board. So it might be something.
Yeah.
Okay. Interesting.
It can now. Now with the stacking, it actually will. But yeah, it's anything that's drawing power. Like that is...
Got it. Okay.
Power.
So it's not... You don't expect people to be driving power. So like overdriving an LED, not overdriving, but just like driving high brightness LEDs through it, that sort of thing. It's more of a... it's consumptive. It's like things that are consumptive,
Yeah.
but still routed point to point because you need to get the power supply. And I guess you do have go
From
ahead.
the rails, yeah, it doesn't go 3D switches. So that if you just did a rail jumper from the rails, that's the backup there. So
Got it. Okay, yeah, that's good. And that wouldn't impact anything, or it would?
no,
I guess you wouldn't set up that connection to anything else if it's just like the VN on a ESP32 board. You
yeah. So there's some software things that will just kind of ignore connections that would clearly screw something up. If you just connected power to ground, it just wouldn't make the connection.
okay?
Yeah.
That's good. Yeah. Another benefit, I guess. You said you're not targeting beginners, but that actually is like, boy, that would help me back in the day.
Especially with LEDs, because it
Yeah.
won't blow up an LED. It's just enough resistance to keep
Yeah.
them from frying.
Right. The
Yeah.
downside being when they finally move off the breadboard and they're like, I don't know, it just
Yeah.
keeps going pop.
I keep
I
telling
need a
people that, like,
resistor? I didn't know
do
about
not
this.
lean on this. Yeah.
Yeah, yeah.
So yeah, that is the worst part.
And that introduces a decent amount of like there's downstream effects from that complexity as well, right? Of like, so now you've got 9 volts to drive this switch, but then also you have the higher voltage that's available, which means that, like you said, with the probe, you have to be able to be tolerant to an errant 8 volts that might make its way back to the micro
Yeah.
or the ADC. So does then everything get divided down at the micro or ADC?
Yeah, all the ADCs are scaled down.
Okay.
And also the last, so it's double buffered. Actually, I may have taken that out. But yeah, so the ADC that, at least on the older ones, it was double buffered, and the second ADC was only powered by 5 volts. So it wouldn't go beyond the rails, and it wouldn't.
Yeah.
But it turns out it's fine. Everything's scaled down to. Yeah, there's the GPIO. That's the only one that's like raw, like no buffering between the microcontroller and the board.
And what is that hooked up to?
So those are routable. So you have
Oh.
8 plus 2 routable GPIO. The other 2 are like UART that you can just say
Okay.
like, and anything that goes, it
So if you have
passes
that
it through.
ESP32 out there, you could like route out to that, talk to it. So like RP2040 could talk, or 2350 could talk to the ESP32 you had, that sort of thing.
Yeah. And
Okay.
so Jumperless shows up as like, we keep adding serial ports, but right now it's 3 serial ports. And the middle one is just a USB serial thing. So anything
nice.
those UART lines, it just passes it right through.
That's nice. Yep.
Yeah.
That's great.
Yeah, the power of finding out that you can make as many USB endpoints as you want. And then you're like,
Yeah.
what? Do we want an endpoint for this? It could be its own.
You get an endpoint. You get an endpoint.
Yeah.
I feel stupid, but I scrolled down the page finally on the crowd supply page, and you do have a comparison chart. Boy, that would have been a smart thing for Chris to pull up at the beginning of this episode. Okay.
I mean, there's nothing else. I mean, there was the SandWiz. That's like the only thing really to compare it to. That's like,
so that's a alternative smart breadboard sort of thing.
yeah. It was a Kickstarter. I don't know if it is shipped or anything, but that uses a Cypress PSOC, which is cool.
Oh, and it last updated 2025, so alive-ish. Yeah.
Yeah.
I don't know when it funded. Funded June of last year. June or July. Okay. And then that one's, that's using KiCad. Looks like KiCad interface sort of thing.
Yeah.
Let's
Yeah.
blink on this one. I gotta say, there's a little less
It's a
blink.
different mindset, and I
Yeah,
appreciate that it exists out there. It's I try really hard to not hide anything from the user. Like you want it to do all the routing behind the scenes, but it should let you know what the state is. But if you don't have LEDs, it's kind of hard. I mean, that was a big jump from Jumperless, OG Jumperless to V5 was it could do all this stuff, but it's not really helpful if you're not aware of what it's doing.
Yeah. That does become a pretty key element, like making it actually interactive.
How else is it worth it to have 500 LEDs on a thing like this?
Yes, right. Yeah, I mean, and so people can, again, they can also scroll down the page like I should have done. But you have, GIFs of like animations that happen on there. You have text interface as you use the scroll wheel in the top left. You can actually like interface with this thing, select menus. That seems like that's how you kind of turn on different functions as well.
Yeah. So I try to make it so almost everything you can do with just the scroll wheel can also just be done with the probe and can also be done over the terminal.
Okay.
It's, it's always hard to juggle all three of those, but it's kind of the philosophy of all this. But yeah, generally scroll wheel is for like more like what set the rails, like do different options, like kind of a configuration thing. And the probe's more for making, jumper connections. Did you see? Oh, so the thing is a lot of the crowd supply stuff is outdated. Did you see I have new caps on the click wheels.
Oh, rainbows.
Ah.
Very nice.
Like full color 3D printing from JLC. And
Oh,
it's like,
yeah. Oh my God.
It's amazing.
All these services that are just like, they keep popping up new things. I feel like they pop up new services before I can even think about what to do with them, But that's a really good use of it.
I feel like it's been around forever and no one's like really used it for anything. But yeah, I have 1,000 of these now. They're great.
Yeah, that's like a handout. You're gonna find those in the wash,
Yeah.
in a jean pocket or something.
Yeah.
Yeah, I feel like the 3D, the full color 3D. They actually used to have that at M Hub, the space I was at, but like I was just talking to someone about this, and it was like you have the demo most of the time. People like print out the demo slice of pizza or the demo donut, and it would sit there, and that would on the tour at M Hub. That was always on the tour. But then it was like, unless you're thinking about this when you're actually designing the part, and then have the capabilities to route the color through. Most people think
and you have to do the whole 3MF.
Monocolor.
Yeah.
Yeah, right, exactly.
Yeah, no, and the crazy thing is I was thinking, like, you would assume that, printing in full color you would be sacrificing some resolution.
Mm-hmm. Yeah.
But no, this is the sharpest print out of all of, I
Really?
ordered these in everything. I have them in steel and like everything that JLC offers.
Yeah.
And it turns out the full color is like far and away
That's
the
cool.
sharpest.
Yeah, I think it's one of the reasons is because it's like an inkjet process versus like some of the other like processes, and like inkjet's that's like little magical spray nozzles, like how they do that stuff.
The crazy thing is those printers are not that expensive. I think
Really?
I can find the link. I mean, okay, they're expensive for
Relative
you
to 3D. Yeah,
they're
yeah,
like 40 grand.
Okay.
For like
versus
the
like 250 for like the super high end like nanometer scale metal printers that are out there. It's like nuts.
Yeah. But yeah, no, and everything on that page, on the crowd supply page, is kind of outdated because they keep adding stuff. Like there's now an FPC connector.
Okay.
So this was a big thing of, people wanted more breadboard. Everyone wants like the full size breadboard thing.
Okay. Yeah.
But yeah, so now what you can do is you can plug in a 20-pin FPC cable and connect it to another jumperless. And then you get 8 analog lines that you can go from one to the next.
Nice.
Or it can just break out all your like ADCs and stuff. So it's like easy to like clip probes to. And
yeah. That's nice. Well, let's talk ADCs and DACs as well. So you have a bunch of other chips on here. So you have an MCP 4278, which is a DAC. You have ADCs on the RP2350. I'm just reading, of course. And then you have current sensors, INA 219. So what is then? So then you're allowing people kind of in situ to measure in addition to just routing. Is that right? Or like, how do you actually hook up like an ADC to a particular line, or I guess, or a DAC?
So on the new Jumperless, so there's if you have a picture of it up, you see around the logo, like where it says Jumperless. If you tap on the guy, the top or the bottom. Or there's also ADC, DAC, and GPIO. Those little little shout
flags.
lines.
Yeah.
Those are how you tell it, I want to connect an ADC line there. That's actually more important. I mean, obviously routing is a big deal, but that's most of it, is trying to be like, give people a sense of like exactly what's going on. And so, yeah, you can just connect an ADC line, all 5 of them anywhere, and the line color will change with the voltage it reads.
Oh, wow. Okay.
Yeah. Same with current. You can say like, hey, this is a current wire. And that will also kind of show you how much current is flowing between 2 connections.
How does that work?
Okay. So yeah, this is what's crazy. So when you have like, this is what's made this so fun and like such a sticky project, is like when you have everything routable to everything, you could do crazy stuff like that. So I have the current sense in and current sense out is just one of the nodes. So if I want to measure current.
Okay. I'm just thinking, okay, so we have 100 rows, and I'm connecting row 20 to row 40. And that's going through the switch matrix, maybe through one of the connector chips, like you said, the IJKL, to make it connect to another chip, and then down to 40. But then it also then has to get routed out through a sense resistor somewhere. So where is that sense resistor in that kind of flow of the thing?
So how you would do the measuring current is instead of connecting it from whatever number you said
to
first.
40? Yeah.
20. You would
Come on, Kevin. It's so easy. I just said 20 to 40. Yeah, sorry.
So instead of like this, Jumperless does this itself on the back end, but instead of connecting it from 20 to 40, it connects it to current sense plus, which is one side of the sense resistor, and then connects the other. Then 40 gets connected to current sense minus, which is the other side.
This is a nanny state breadboard. It's telling me.
Yeah.
Okay.
One of the DACs is also like hardwired to a current sensor, so you can measure resistance. So if you want to measure a resistor, you can it'll hook one side to ground and then, give it 5 volts and how much drop it is. That's your resistance.
Yes, that calculates. Yes.
Yeah. Also, a weird thing is so the probe only has 4 wires. How to figure out which position the probe is in, there's a switch on there. And that switches from the probe output is like just a GPIO pin driven to 3.3 volts. That's how it measures where you touch. When you switch it, it's a DP dual pole dual throw switch. So it swaps
switches all the wires around.
Yeah, it switches them all backwards. And so the other one is now one of them is powering the LEDs. And when you flip the switch, the other one switches to powering the LEDs.
Oh, wow.
And then your measure input is on the tip of the needle. And how it knows how you do that, there's no way to tell. It powers the LEDs through the current sensor and knows whichever one is drawing current is which one is powering the LEDs.
Wow.
When you have an arbitrarily routable matrix, you could do weird stuff like that.
Have you tried to get so you said you commit paralleling paths. Have you done like this? I guess you probably I didn't need to look at the page, but I think I've actually remember seeing this. So this is probably not even. But you've done snake, and have you snaked the signal as well, like all the way around the board and stuff like that. So like, could I go from pin 1 to pin 4 to pin 3 to pin 2 to pin 7? Like could you put them like literally all on the line? Is that something that's possible, or I'm not saying you?
What do you mean, like
all the pins connected like through the matrix and back through again, like literally like looped like spaghetti connection all the way back through?
You mean like connect everything to everything kind of thing?
Yeah, I guess so.
Yeah, it'll do that.
It'll do that?
Or unless you mean like there's the opposite of path routing, path stacking, where you can make it like a high resistance.
That's exactly it. Yes, that's what I was thinking.
Yeah.
Yes. I don't know why you want to do that, but really big resistor, I guess.
You can, like, if you need like if you need like a sense resistor for something else, you can.
Yeah.
I have not written the code for it, but yes, you can do that.
Got it.
I think I figured out how I'm going to do it, though. You just have to promise it
So
that you're not. I've actually thought of it because people ask for it.
Yeah, no, just when you were saying like the arbitrary connections, anything to anything, it's like, what are the weirdest things you could do? Like,
there are. Yeah, it's crazy what you can do with these. I'm trying to think of like the weirdest little hack. I don't know.
Yeah.
There's also there's a buffer in there. You could probably buffer it back to itself and just make a ring oscillator just with the.
That's good. Yeah.
Yeah.
Yeah, like make like a theremin out of like a resistor and an inductor or something like that, and just start to.
Oh yeah, use the traces as your inductor.
Yeah, it's very interesting to have all this stuff in there, and you have all the visualization too. It feels like it itself is kind of it is an art project in addition to a tool. Are you seeing people like program it, like kind of hack the interface and then start to do weird things with it, or are they mostly just using it?
No, I mean, a lot of people are, I'm actually, there's someone with the original Jumperless right now. They're working on a library, like a Python and an Arduino library. So an Arduino Nano sitting on the top of the breadboard basically all of your control stuff is on there. So you just do it with calls, which I think is actually a better, then you don't have to like deal with my code. You could just deal with your own operating system basically, and it will send everything.
Got it. So it's like an API level interface to like the DAC or the ADC or what? Yeah, right. I guess it's
and it just puts everything on your own chip that you can mess with. A lot of it does attract the kinds of weird nerds that want to really get into it. You know, it's cool.
Yeah, that is nice. That's a good user base to have. They'll help up the game. Yeah.
Yeah.
What is the so on the interface? So you'd said you can use the probe. You said you can use something like a walkWe or some kind of external. But then what is the, I guess it's command line to then interface otherwise? Like what is the normal triggering of different functions without the probe?
So it's actually the same app for the old Jumperless and V5. It just knows which one it is, but it's just terminal. Like you could run Xterm or PuTTY or whatever. Xterm is probably not right. That's a standard. Okay. But yeah, just any like random serial terminal.
Screen.
And it's just setting.
Yeah.
That's what I'm actually, the app uses a screen. And so that the API is just, it gives you a menu and it's like a bunch of one letter commands, which is lame because I'm running out of letters.
Because that's actually kind of how like Bus Pirate looks like too, right? Or at least old Bus Pirate. I don't know about new Bus Pirate, but yeah, it's all just
and that's
shell,
I think
right?
Yeah, exactly. And I think I've been talking with Ian about that because I made one of those things is like actually a Bus Pirate adapter now.
Oh,
like,
cool.
You can plug it into the FPC cable and they could talk to each other and like you could use a Bus Pirate on a Jumperless and it's like auto routed.
Have you looked at all the shells in? I'm going to get into my day job stuff here, but have you looked at all the shells in Zephyr? I don't know. So Zephyr runs on the 2350 now. It just got ported. And the shell capability. So now it's like instead of a single letter, you could just have like crazy amounts of like the shells that are built into Zephyr are like, I'm actually writing a blog post about it right now. And it's just like the number of things that are in there. Like there's a sensor shell, there's a I2C shell. So like a lot of the things that are out there, they're just built in.
It's God, magic. That's so much better. Maybe I'll steal all your code.
That's not my code, it's Zephyr code. It's not. It's
in
the RTOS.
Okay.
Yeah. But it's
always
really
looking for that
impressive
stuff.
Yeah.
Yeah. But yeah, so the actual like the API now, like if you want to make connections, I make everything, it's really as dumb as the letter F and then like I want to connect 20 to 40 and it's 20-40 and that will connect 20 to 40.
Right.
Like that's it.
Right. Yeah, that's great.
And then it saves it all in text files. It's got a file system. So you can like, you can mount it and you could just share. Like if someone has a whole setup, you can just be like, all right, share that with someone else.
Oh, that's nice.
Is
it because you're also writing your own, like you're writing a UART handler basically, so it's like it's just easier to like switch off. Hey, I just got an F. Now I'm in this part of the program, and now I'm doing this and this and this. Yeah.
Yeah, there's like no libraries in this. I don't trust libraries. I'm like a weird old curmudgeon C guy.
Suggested an RTOS to you. I don't think that's not gonna fly very well. Okay.
I wrote my own mutex because I don't trust the mutex on it. It's like I want to know how this stuff works.
Okay. That's got its own flavor. It's a flavor. It's not.
Yeah.
It's not right or wrong. It's just. It is what it is,
Yeah, I mean, I try to be compatible with everything else, like, of course, because that's a dick move. You have to learn my language, but I try to keep it just simple enough. Someone made this is totally separate. Someone made an Excel, like, using Excel has a serial port, a thing that will send paths to a Jumperless through that.
Nice.
But it's like that. It's meant for that kind of stuff that you don't have to do a bunch of, like, command on stuff. It's just like send it a list.
Yeah, that's cool.
Yeah, I like it being like just human readable. I think is the big one, but we always add stuff. So
yeah, well, and that's the thing. I think over time as code base keeps getting more complex because you add more features, it sounds like your community's with it too. So like that helps actually because I feel like the lone inventor, like just if it was just you forever, and then like 20 years from now, someone's like, oh, I want to take Kevin's work and extend it.
Temple
it's like
OS or something.
Yeah, exactly. They're gonna be like, what? He came up with everything. But at least if you have people in the loop now where they're like, this doesn't make any sense.
that always happens on my Discord. Is someone will like, hey, can it do this thing? And then I like start grilling them with questions like, how do you want this to work? Like, what? Just first thought, how do you do this? Yeah.
All right. Well, there it is. If you go in Kevin's Discord, watch out because you will be asked product questions.
I love that stuff. Like most features are written like that. Just someone like, hey, could it do this thing? I'm like, well, it can't, but give me 20 minutes.
Yeah, exactly. Yeah. Well, that's great.
It's weird, like working with the same code base long enough that you just know it off the top of your head. Where you're like, oh, I know exactly what file, what line to go change to make that work. It's super weird.
There was a talk I was watching where it was a game designer, so like someone writing a video game in C, and they were, I forget what it was for. It was definitely a conference talk, but this person was like, I don't want to say. They were idiosyncratic. That's the nicest way to say this. They're like, everything is in one file.
Oh, jeez.
An entire video game in one file. And it was just like, I think they said like, oh, I know where everything is. I could search for anything. It's like, I could see the logic in it. And it's like, man. And like from a performance standpoint too, when you think about like video games often need to be super performant, like maybe, they often had to optimize a bunch of stuff. But listening to the talk, I was like, oh, this is not me. That ain't me.
I kind of love it. I like the idea of doing that. It's like I pound include every other file in every other file. Yeah.
It's like you could have a multiple choice test of like, do you agree with this method? Do you agree with Kevin's method? Do you agree with the C programmer, the video game programmer's method? And it's like you could, be somewhere on like a chart of like how close are you to the hardware?
Curmudgeonly graybeard chart.
Yeah,
like,
exactly.
I don't trust other people's stuff.
Yeah. My programming language is solder.
But no, I do find that like a lot of libraries are great until you want to do anything specific, and then
you're re-implementing it.
Yeah, and then I'm just like, I'll take a library and like kind of take the parts I need and make it. This is a weird piece of hardware too.
This is not a normal. We've not seen this on the show before.
yeah,
Which is great. That's why we wanted you on here in the first place. That's great.
But the idea is
wanted to. Oh yeah, go ahead.
No, but the idea is it should be fun. Like that's why I am like this, is because most programmers are like, to them it's simple. Like to them it's really simple to like curl bash blah blah blah, like write this whole command line argument, and I'm like, nah, dude, I don't. You shouldn't have to learn that.
How about F?
Yeah.
So if people wanted to pick one of these up, if they want to see where kind of what's under the hood, how do they start finding you and finding your stuff?
So there's Crowd Supply. It's probably the first one, and then GitHub for both of those. I tend to keep that somewhat up to date, and then whatever social media you use. That's how you get your development updates as they happen.
Got it. Yes.
I usually
Blue
go
Sky
through all my
is how Kevin and I interacted. About this sort of stuff. So yeah.
And so I'm Architeuthis Flux on Blue Sky. I have to go find what my handle is.
I'll link it for those things.
Okay, cool.
Yeah. Okay, great.
I like
and
questions.
You have a Discord server? Is it like a Discord servers for people that are kind of co-developing, or is it more users as well?
It's actually a really good server. It's like most of it's off topic about random stuff. But,
that's great.
Yeah.
That's what community is, right? It's getting together for a certain reason, and then talking about other things you're working on.
It really did. It did a good job of turning into like a nice community where everyone's like
that's
just hanging out there. Which is
yeah.
And that's how I get all my user data. So if you want to come in and tell me something you want to see on it, that's where I'll see it.
Well, we'll link that in as well. Kevin, thank you for being here. Thanks for making a really cool product and telling us about it and all the things you learned about these great chips on board. So appreciate you being here.
Thanks for having me on. It was awesome.